target today is I can convert rational numbers to different forms, and I can order rational numbers on a number line. We've been just recently learning what does it mean to be a rational number. So if we take a look at this word here, we talked yesterday about comparing rational versus irrational numbers. So if we sort through that, I think I'll actually move to a new screen just so we can kind of take a peek at what we know about that, is that we have rational numbers and then we have irrational numbers. And all of our work pretty much in this course really mostly has to deal with rational numbers. So let's go back as a quick reminder of what it means to be irrational. It's kind of when you have an decimal. And the only way to get an decimal is if you take the square root of what we would call a rectangle. That always results in an decimal. So a decimal that is not repeating, there's no pattern, and it never stops. And the other thing that is considered irrational is pi. This gives you a super yucky decimal, and all the square roots that are rectangles do as well. Rational numbers is everything else. Anything that can be converted to a fraction in any way. And that includes like repeating decimals. If you take 0.33333 repeating, that does convert to the fraction 1/3. So decimals with patterns are actually quite nice. So that's just a reminder of what rational, irrational means. Now let's get through the content of this. So our first job is to basically convert this to a different form. So what's given there is a mixed number, 4 and 3/6. So really kind of saying, 4 plus 1/16, I guess I said 6, but I meant 16. 1/16 plus 1/16, that's really what's happening there. So we have 4 wholes plus 3/16. So if we were to convert that to a different form, we could convert that to a decimal. And by doing that, first of all, there's a button in the calculator that allows you to convert from a mixed number to a fraction or a decimal. And so that would do the work for you. But the other option is you can multiply these two, which is 64, and you can add the top number, which is 67, and then you would divide by 16. So I'll quick review that. You should have learned that in elementary school. You would multiply these two, and then you add the top number 3. So if you have 16 times 4, and then you add 3, and then you would just simply put that in your calculator. So it would be 67 divided by 16. So if we put that in our calculator, 67 divided by 16, that gives us 4 points. If we were to round that 19, why don't you go ahead and type that in and make sure that you're getting 4.19 for that first problem. So that's just taking a mixed number and turning it into a improper fraction. This is called an improper fraction when the top number is bigger than the smaller number. And then, of course, the decimal equivalent that goes with that. That's just completely using my calculator, by the way. So what happens if it's negative? So negative, we basically just keep the sign out front and let it wait like we always do, and then we're going to reattach it at the end. So we're simply going to multiply these two numbers, which is 3 times 9 is 27, and we're going to add the top. So that's 27 plus 4 is 31 over 9, and we're going to reattach the sign. So that becomes negative 31 over 9. So that's your improper fraction. Catch up, catch up, catch up. Make sure you're doing it. And this gives you a nice repeating decimal of negative 3.4. And I'm going to round just to the 10th here because of the repeating decimal. And that proves that repeating decimals are rational because they came from a fraction at some point. All right. So I'm going to go do this one on the end here just because of space. Actually, I'm going to get rid of this one and I'm going to keep this one. Oh boy. So I'm going to cut some of these just because I think the video will get really long if I don't. So here we go. We're going to keep that sign out front. Just keep it there. Leave it, leave it, leave it. And we're going to multiply these two, which gives us 25 plus 2 is 27/5. And then we're going to reattach the negative. So then we're going to simply put that in our calculator. Put that in. You know it's a division problem, right? All fraction bars, that means divide. We're just dividing down. Becomes negative 5.4. That is not repeating. That's a terminating decimal, which is also rational. So everything on this page is rational because I don't see any square roots on the page, and I don't see pi. All right. So what about so those first ones were given a fraction. So now down below, if I were to maybe set up the highlighter there so we can kind of see that we're setting a different section. Down below is all fractions. So if we take the fractions, we would get that would be, we take the fractions, that would be 4 and what? 5. 5 what? 5 tenths, because that's the 10th position. 4 and 5 tenths. And if we were to put that in lowest terms, we would end up with 4, and that reduces to 1/2. Because what we can do is we can divide this by 5, and we can divide that by 5. The top by 5 and the bottom by 5 becomes 4 and 1/2. So basically we're going in the opposite direction, taking a decimal and converting it to a mixed number. So what about if it's negative? So let's go to this one. Well, it's the same. We're just going to pull the -3 out front. The negative just sits there. And we're going to talk about the place value there is the 10th place. So again, that's the 10th place. I guess I should have used a different place value, but the 10th place. How many tenths? 1/10. I'm having trouble with that there. So we end up with -3 and 1/10. -3 and 1/10. Cool. So that's the first page on being able to convert from a mixed number to an improper fraction and back and forth. So let's take a look at some questions about what we know here. So in the upper left-hand corner, it says the number 0.25 is rational because it can be written as a fraction. So we have 0.25. And we talk about places. That's the 10th place. That's the 100th place. And how many hundredths do we have? 25. So the question is, does this reduce? Can we reduce that? Are there any common factors that we could take out of 25 that we can also take out of 100? And you should be able to see that, yeah, there are. Common factor of 25. So we can divide the top by 25. That gives us 1. We can divide the bottom by 25. That gives us 4. So 25 cents is really 1/4 of a dollar. It is really 25 out of 100 cents. If you think of a dollar, it's really equal to 100 cents. So 25 cents is 25 hundredths, 1/4. So your answer here should be B, that they are equal to each other. They're just in different forms. One's in fraction form, lowest terms, and the other's in decimal form, but they are both definitely rational. All right, let's take a look at the next box here. I'm going to erase this just so we have some space to work. The number square root of 4 is rational because we know that the square root of 4 is equal to 2. It's a 2 by 2 square. So what fraction does that equal? Well, the only one that it would equal is the fraction 2 over 1. So we can always place a 1 underneath to make it into a fraction. But we know if we take the square root of 4, we're asking for what square, what is the side length of this square? Answer should be 2. All right, next box. The number 0.454445 is rational because it can be written as a fraction. So we're really talking about this repeating decimal where these digits repeat. So we end up with 45 hundredths. 45 hundredths. And granted it's repeated, so I'm just kind of simplifying that with that bar. So I'm looking for factors that I could take out of 45 that I could also take out of 100. And so when I do that, I know that 5 goes into both. So if I divide by 5 here, I get 9. And if I divide by 5 here, I get 25. 9/25. Do any of those look like 9/25? No. So now we're looking for something that's the closest to that, right? The closest to 9/25. So another strategy when you're in a situation like this with a repeating decimal and you're having a really hard time finding like which answer could be the closest to that, here is another strategy that I'm going to show you is, and we can go back to that as well, but what you could do is you could type these all in your calculator and see which one is the closest to that. So if I type 3 divided by 5 in your calculator, why don't you go ahead and do that, 3 divided by 5 in your calculator, and you should get 0.6. And is that the closest? I don't think so. When you type 4 divided by 5, you get 0.8. Maybe I'll just do these for us. If you type 5 divided by 11, what do you get for 5 divided by 11? Ah, you get that repeating decimal. Winner, winner, chicken dinner. This is exactly that decimal. So sometimes with those repeating decimals, and when you round it to 45/100ths, you just can't get it right because of the rounding that occurs. So sometimes a backdoor strategy would be to type them all in your calculator, get the decimal equivalents, and see which one matches. So answer should be C. All right, next problem. So here's my first decimal. And I'm going to compare it to this one. So we're comparing 0.125. And this would convert to 1 divided by 5. 1/5, 1/5. Put that in. You should be getting 0.2. Now the dilemma here is they're not in the same place value. They're not in the same place value. So that's tenths, hundredths, thousandths, tenths, hundredths, thousandths. So we end up getting 0 and another 0. Now we can see which one's greater. This one is greater because it's like 200 thousandths compared to 125 thousandths, but we gotta put those placeholders in. So how I got that is I did 1 divided by 5, I got 0.2, and then I filled the placeholders because we need them to be equal in place value, and you can see 200 thousandths would be greater than. So the answer then should be, oh, I should have said less than. Less than. Answer should be A, less than. All right, so we're at the 12-minute mark in the video. I don't know why that happened. Let's take a look at some other questions. I think I'm going to skip those two because of time. So let's do the next learning target, which is I can order rational numbers on a number line. All right, so we probably won't do all of these. Well, maybe we will. Let's do the easiest ones first. All right, this one, 0. Where would we put that on the number line? No big deal. This one, -2. Where would we put that on the number line? No big deal. This one, where would we put that on the number line? Well, -12 divided by 4, it's a triangle problem, is equal to -3. Where would we put that on the number line? No big deal. So we've done that one, and that one. So what's left then are parts. So we're going to figure out if we pull out the parts, we'd be in good shape here. So 7/3 is really 3/3 plus another 3/3, because that's 6/3. That's 6/3, but I need 7/3. So this gives me the 6/3. So I have one left, which is 7/3. So that gives us 1 whole, 1 whole, 2 and 1/3. Pause that video and watch that again if you're confused on how I pulled that out. Third, we're going to cut the pizza into 3s. We have 7 total pieces, so I'm going to pull out 3/3, another 3/3, which is 6/3, and I have 1/3 left over, so that's 2 and 1/3. And if we go ahead and graph that out on my screen here, 2 and 1/3 would be, you know, somewhere in there. Whoa, somewhere in there. All right, so that one's done. All right, I'm a little bit out of space here, so I might erase this and then just draw a line down. I actually might erase this as well. All right, so let's take a look at negative. Now, negative just means direction that it's in, the location, the actual amount or the quantity that's processed is the same, but it's the direction. So we're going to keep a negative out front. We're going to group these into 2. So we'd have 2 over 2 plus 2 over 2. So that's 4 of them. I need 1 more. So that's 1 and a 1, which is negative 2 and 1/2. Why negative? The negative just goes with us on the right. See the negative out front? We just take it with us. So you got your negative out front, we just take it with us. So that's 2 over 2, 2 over 2. That's 2 full pizzas and 1/2. So negative 2 and 1/2 would be right here. Negative 2 and 1/2. Graphing on a number line. All right, let's go take this last one over here. Negative $3.25. Oh, I don't even need to do any conversions on that. Negative $3.25 would be over here. Negative $3.25. Cool. All right, we're at the 15-minute mark. I'm going to take a peek at other ones and see. I'm not going to order those least to greatest. Not going to probably do those. I might do a couple improper to mix. Yeah, let's do a couple improper to mix. Okay. So if we take a look at this top one, we would be multiplying these, which is 8, adding 7. 8 times 1 is 8, plus the top number is 15/8. So your answer should be A. So multiply the denominator and the whole number, and then add the numerator, A. So you try this question right here. Go. So pause the video, try that question. Okay, should have unpaused the video. We're going to multiply those two, which is 27. And then we're going to add the 5 that's sitting on top. So that's 27, then we add the 5. So it's 28, 29, 30, 31, 32. And I don't remember what the denominator was. Was it a 3? Whoops! It was a 9. Over 9. So 32 over 9 would be the improper fraction in that conversion. So we're going to do down here is the exact opposite of what we just did. So we have 31/4. So I'm going to pull out how many 4s fit into 31? 7. 7 4s do, because that makes 28. So what's the remainder on that to get to 31? 3. So 29, 30, 31 are 3 left over. So then that would be 7 3/4. Again, pause that video and watch it again if you're having a tough time with that. But I was asking how many 4s go into 31. I came up with 7, which gives me 28. So I was trying to figure out my remainder then. And I realized there were 3 left. I'd like you to try that last question there, converting. All right, so you should have tried that. You're unpausing the video. If you've not done it yet, you should be doing it. But 28/8. So the question is, how many 8s fit into 28? 3, which is 24. What's the remainder on that? 4/8. Or